Hi, this is a presentation about an aircraft's induction system, specifically for a reciprocating engine. I am your presenter for today, Crassius Xavier Pascual. And before we proceed, I wish everyone their safety and, of course, their family's safety. And I hope we could all be productive during this quarantine period and make use of our time, to help someone or to do something or learn something useful. So, what is a reciprocating engine? A reciprocating engine, also often known as a piston engine, is a typically heat engine, although there are pneumatic and hydraulic reciprocating engine that uses one or more reciprocating engine to convert pressure into rotating motion. So basically, we compressed fuel and air via through a piston or via piston. Then the combustion provides us provides us the power that we need to make an airplane move or fly. So this is quoted from Wikipedia. There are also different kind of reciprocating engine, and I will be putting it in your screen in front of you. So I would be showing it to you. So we have six different kinds, and I think there are more, but I'd like to show you six different kinds of reciprocating engine. So we have the inline vertical engine. So basically, it's aligned to each other, and we have the V-type engine. So if you look at it in the front side, you'll see a V-shaped uh, engine, and then the second one is horizontal engine. So yep, it's if there's a V-type engine, there also the horizontal engine. So it is aligned horizontally, and we have the opposed cylinder engine, and this also looks like uh, this is commonly used for Cessna planes, and we have the W type engine. So it looks like, or it shapes like a W for if you look at it in the front side. And then we have the radial engine. So it is basically composed of eight piston engines that are in a circular shapes. And then those are some kind of reciprocating engine. And as I've mentioned earlier, reciprocating engine and their definition. And now we're going to proceed with the induction system. So induction system is basically from the word induced. So to induce fuel and air that needed for the combustion. So the induction system brings in air from the outside, mixes it with fuel, and delivers the fuel and air mixture to the cylinder where combustion occurs. And with the carburetor, the air and the fuel is mixed inside a carburetor. And then we have the fuel injection system. It mixes the fuel and air immediately before entry into each cylinder. So basically, each cylinder has a fuel injector, and this system is much advanced than a carburetor, and basically and obviously lighter in weight. But we can talk about pros and cons later. To explain further, what is induction system? So there are two types of induction system used in our small to medium aircrafts. It is the carburetor type and the fuel injection system. Now, what is the difference? Well, the carburetor type uses a carburetor for fuel and air mixture. Carburetor type will be explained right after. While fuel injectors does not have carburetors and it uses a fuel pump. It has a different mechanical system for fuel and air mixture, though has some similarities with the carburetor type. So there's not so much of a complexity between those two. Since this is all about reciprocating engines and the carburetor types are mostly used in reciprocating engines, we are going to talk about it more instead of the fuel injection. Now, before I get to explain how it works, I'd like to give you a quick explanation of the components of an induction system. Well, we are all familiar with this figure. Now that is the process of the induction system, or some parts. Well, the first component is of course the air. I will be flashing it again in the screen. The air. It is the only natural component which is essential to make the induction system effective. These are not in just a disclosure. These are not in chronological order, or meaning to say, I will not be explaining this from the most important to least important. Well, I'm just going clockwise. There are two types of air needed for the induction system. One is the warm air, that is the red arrow on your screen, and the other one is the cold air, which is the blue arrow on your screen. I believe there are legends visible for you. Both are essential and should exist coherently, because if one exists independently, surely it will not work. And the second one is the air filter. This is the component needed to make sure that the air is coming in, or the air coming in is not harmful to the engine's mechanical system. It basically filters the air to avoid entry of any substance or debris that could damage any mechanical component. Third component is the carburetor air valve. A valve simply means a door or an entry or exit point that is particularly or but this particular carburetor air valve is just used as an entry point for the air needed by the carburetor itself. Specifically, hot air is entering at this point or at this part of the induction system. Then, of course, the fourth component is the carburetor. The carburetor's main job is to mix the fuel coming from the fuel tank, of course, and the air coming in from the carburetor's air valve and the air intake duct. On the side, there are two different common carburetors, or carburetors mechanics. It's up to you whether you want how you call it, the downdraft and the updraft. There's also an uncommon type, which is the side draft, but it is rarely used in an aircraft. But the first one commonly used in the aircraft industry or the aviation is the updraft carburetor, wherein the air enters at the bottom going up, and we have the downdraft, so wherein the fuel air is coming from top going to the bottom. The difference are simple between the two different kind of carburetors. And then the fifth component is the temperature bulb. This measures the temperature of the carburetor to prevent overheating or icing of the carburetor that could result to clogging or the airways, or what we call valve. Then we have our sixth component, which is the drain line. This line serves as a declogger as well, because it drains the carburetor to prevent moisture that could lead to clogging or any fuel leaks that could cause clogging in the system. Without this component, our induction system it could fail because of clogging. The seventh component of induction system is the cold air actuator lever. It basically controls the cold air coming in the induction system to avoid icing and the seventh component of the induction system is the cold air actuator lever. It basically controls the cold air coming in the induction system to avoid icing and rich mixture of fuel and air. Because if we allow too much cold air entering the induction, ice can be formed and result to clogging. It is called a lever because a piece of metal is hinged by a bolt and a nut. So basically it moves up and down. That can close and open voluntarily when the cold air is sufficient for the mixture, so it moves voluntarily. It moves by itself through a mechanical component that is, configured by the engineers. I'm sorry if I cannot find any pictures of it online, so please bear with me. The eighth component of the induction system is the air intake duct. This is an airway where the cold air is entering, and it serves as the esophagus of our lungs, wherein our lungs is the induction system or the carburetor. So that was a brief explanation of the parts of induction system. And I believe the figures also show how it works. So it is also connected to a throttle body because a pilot needs to have a control of the mixture of the fuel and air in the carburetor going to the piston for combustion. We have two control for the cockpit. One One is called mixture throttle, and the other one is the throttle valve mixture, or throttle valve. Sorry, mixture throttle is used in control whether you need reach or lean mixture needed in certain altitude or flight condition, because of course, the higher you go, I believe you need a richer mixture, and then the lower you go, you need leaner mixture. So I was explaining earlier, we have components that is used to avoid icing, because carburetor type induction system could be on icing condition as high as 100 degrees. So that is pretty high to produce an ice, but yep, it is still possible if you use a carburetor type. So this is why we need to monitor and control the temperature in our carburetor. Now, what are the common issues with carburetor type induction system? One is carburetor type induction are usually prone to overheat, and we all know that. Cars with carburetor engine usually overheats, and then it consumes a little more fuel than a fuel injector, because that is the main asset of a fuel injector. It controls the fuel that is sprayed or injected in the cylinder. And the air intake leaks, because of a carburetor, due to the usual overheating, it could lead to air intake leaks, and carburetors are easily worn out. Carburetor mounting, it is another part. So basically, if you have a carburetor engine, you will be having one more part than a fuel injected engines, which is the carburetor. So it is mounted, and usually, or actually sometimes, the mountings, they got loose. So there are also good things in having a carburetor type induction system, both in aircrafts or any vehicles or motors. Carburetors are known to give more power. Yep, they are known to be efficient, and they give more power to the motors, and it costs less. If you buy an airplane or an aircraft that has a carburetor type engine instead of a fuel injected, basically you will buy it for a less price, and it has a lower maintenance and repair. If you take care of everything, if you take care of everything well, and if you do the proper maintenance, it will be less for you. But carburetors needs less or requires less attention than an